Hello, that's our CSCI 465. Okay. For today's class, we will discuss a topic like in the previous lecture, we talked about using blockchain, okay, to enhance the security. And also in the lab session, also try to demonstrate, okay, how can we encrypt data send it to using blockchain. As a follow-up later, you will try to show me how you can read it. Okay, so it's a quick task. Okay, make sure you're able to do this part. And when we move on after blockchain, of course, it's a hot topic. And nowadays, maybe it is because like okay, using apply AI machine learning for smart things security. So just like repeating, just have a recap. So we talk about the privacy, okay, and then the personal data and safety. How can they those attacker can compromise the physical safety? Okay, so they can really hacking the camera. Okay, those like some smart lock. Okay, and also of course they can manipulate the data. They send some false information. And so for example, data integrity. Like if you're thinking maybe in the like household, okay, maybe small things, but if you know we talk about the smart city, okay, if they really able to control the traffic light, then it's getting more serious. Of course, if they steal some sensitive financial information, okay, or disrupt the business operation, then will cause a huge financial loss, as well, you know. We always say target on like those that already know the consequence of those weak securities, okay, including the unauthorized access, data theft, like device hijacking. So we always talk about hijacking. Also, we can do the malware infection too. Okay, so all this will affect the security, and we'll be quickly go through like including the unauthorized access and also we have like interceptions including man in the middle. So that's we try to avoid, and then the hijacking them they will taking control, okay, of devices, okay, and for the malicious purpose. And also we can have the botnet to compromise the IoT devices so they can launch the DDoS. So that's we want to avoid those issues, okay. And as like two things pretty common, okay, we will security threats happen in the security. So we keep talking. So they'll continue like collecting, sharing your personal data. So they will lead to some significant privacy violation. Also, maybe the devices can be like affected with the malware, so they can steal your data and disrupt your operation, even affect your other operation in your home or like even your city. So or like if we talk about the industrial, okay, so it will cause the industry, okay, itself. And when we talk about AI, okay, so of course in the courses, you have some basic understanding. So just like introducing, we talk about the AI, so it would be the simulation. Okay, so it's a human intelligence. Also, we talk about the machine, and then we try to program and think like human. Okay, for all time, when we design, it's more like specific for a task. Okay, some tasks maybe engineering the assistance, right? So right now we have the three optical AI, so they're capable of perform any intellectual tasks can human do, or then nowadays we have different model. Okay, so we can use it, and possible like we can use or maybe like apply. So right here, including ones that got the natural language processing, okay, so NLP. If you look at the related to AI application, so NLP we use it a lot. So it will be a language translation, okay, and then the sentiment analysis. Lots of devices, especially if for the smart home, those devices, they were taking like those like language, like because we need to handle, okay, not even the language. Sometimes maybe nowadays like can they recognize certain dialect, okay, or they able to handle certain accents, okay. So then it will be much more powerful, and including the computer vision. So how can they do the facial recognition, object detection, okay. So maybe cameras, okay, and also like robotics, including self-driving cars, like drone navigation, all this. because in our lab or example, we of course like focus on the small or home but for the whole industry, okay, even like as big, even for the self-driving car like autonomous car, okay. So all the components inside we can call the smart things, right? They are devices, some we call the IoT, Internet of Things, okay. They can cut like kind of like components of it, okay. Even a drone, okay. So you know like say Amazon and then try to deliver a package there within drone. Okay, so all these can be applied, and it's a subset of AI. We talk about machine learning. Okay, so machine learning we talking about it allows the computers so to learn from the data and improve over time. So without being explicitly like programmed, so it's called the machine learning. So we have to pass the training data and then giving different model and put choose the algorithm. Okay, so we can train it. Okay, so the categories including um, of the machine learning. First one is the supervised learning. So we will train with the label data. Okay, so maybe we can detect things like spam emails. Okay, or may detect certain login. So we can use it. We can supervise it. Okay, and of course we can have something called unsupervised learning. For the unsupervised learning, can be the model we try to identify the pattern in unlabeled data. Okay, costing data point. Okay, and something we didn't label it. Nowadays that you see most a lot, and then you just give it, okay, you just return it. Okay, so this one is more like giving feedback, okay, it's correct or not. So it's like before we train it. So this is called unsupervised. And for the reinforcement learning, so it will learn from the interact thing with an environment receive the feedback. So let's say we train the robots to navigate. So okay, so they will try to calculate the direction based on detection. Okay, so okay, once they hit certain obstacles, maybe they detect an object, they will try to looking for another route. Okay, or finding another better path like this. Okay, so that possible. So it's called a reinforcement learning. So we have like these like categories. In our real world, of course, in behind machine learning, including the Netflix or due to Amazon, they will learn to your habit. Okay, so they can recommend you. Okay, long time ago they were using the some equation like to predict okay what you may like, but nowadays they will based on like the all those labels or the interaction. Okay, and to see. Okay, so maybe probably you're like or based on some categories you're always browsing, they will like um feed you something okay correlated. Okay, they're possible you may like. And also the autonomous vehicle does have driving car, so they can use the machine learning to navigate avoid the obstacles you see nowadays. Okay, that's how they apply. You know, Tesla. Okay, so they were doing detection and then doing some precaution. Okay, and that's what they're doing. Then how can we, okay, so we have two things. One is about smart things securities, and one is about machine learning. Okay, yeah. Then how can we put them together, like combine all this together? One is called the real-time threat detection. Okay, can we analyze if there's a massive amount of data in real time? Okay, can we like identify those threats faster than human? Okay, because you know our when our policy, okay, or the rules we set up, maybe we have to wait for like once they being attacked, and then we have a log, okay, or like the service down, then we can have taken certain reaction. Okay, then how about is it possible like in real time? And can we like trace all the data? So is it possible faster? Or can we have some automated security measures? So can the machine learning, the models we train, okay, can it automate tasks like update the software, monitoring the network traffic, and also like detect some abnormal activities? Okay, so is it possible like it can be a research topic? So can we try to figure out, okay, maybe this memory location is first time, or like why there's some location like keep login or have a fair login, okay, or access. Okay, so then we will thinking about that. Okay, of course there's some patterns recognition too. So can be like detect the patterns. Like machine learning they were good at detecting it. So it think identicate some potential threats. Okay, maybe I think unauthorized login attempts. Okay, some remote access connected the API, okay, all this, and also the adaptability. So it can add some new or like emerging security threats without needing the manual intervention. So because in when we discussed before, so if in case there's some new way, there's a framework battle. Most of the time we need to have a recovery, okay, and then maybe we have backup. Okay, so we always like because for prevention is really hard, but for the AI model, maybe it's possible if there's something new friends appear, can the AI model quickly adapt to it like faster than human, because they can do like 24 hours like monitoring and then adapt to it. So we don't have to manually wait for the people, okay, to interact with it manually, like handle all this situation. And that's a good idea. And normally like detection, so can we like train the model to recognize those maybe like normal patterns of behavior. So we always thinking how can we change those? That was a normal behavior pattern. Okay, if regularly like maybe from a certain address, maybe home or like a smart city traffic, like all those things. Okay, so they will be like we can label them as a normal. Okay, and if there's some flag, we can diversions. Okay, so we could anomalies, like then we can indicate okay as a security threat, and then we can report it and then taking certain action. We can like if they fail to access, they can ban the connection, um maybe log it and then report it. Okay, so everything. Okay, and then the intrusion detection, so we can use the machine learning to analyze those network traffic. So maybe as a sign of a hacking attempt, okay, maybe some malware or some botnet. Okay, so once they detect it, so we can have certain respond. Okay, to take action. Also, of course, we can do some like predictive security. So let's encrypt the past instance and predict okay in the future what the possible threats may emerge. Okay, so it's one of the good way to doing like always like doing precaution better than like to doing recovery. Okay, and then behavioral and analytics, it can help us to identify the security risk. Okay, we can analyze maybe the users or some user performance actions. Okay, and also some the device behavior. So if we can see some unexpected like access to the device or some like unusual data flow expression, okay, normally the data was embedded to server, why is suddenly like go to some another new IP address server and they copying, okay, keep on copying data, okay, or streaming some data to certain location, then we can analyze those behavior, okay. And right here, what are some key techniques can be used for the machine learning, like applying the security? Of course, the classification algorithm, so we can categorize those data, so we can determine if their behavior is malicious or normal, so we can train it. Okay, so okay, those behavior they will be like say normal. Okay, or for another type of behavior will be malicious. Okay, potentially. Okay, custom algorithm. So this one we grouping some similar data point together. Then we can identify some new things. Okay, so where like previously or the unknown, then we can get some certain patterns. Okay, and no, okay, it's possible like that. So it's a custom algorithm and decision tree. So it can help them making the decision. So break down all the security problem into a tree and then getting some possible solution based on the features. Okay, so let's say we measure like for the let's say start from the login and the firewall. So what's the possible solution? Okay, for login, then we can ban the login restrict the login. Okay, but if they already have some malware already injected, okay, so they will try to send data. So what we're going to do maybe like stop the outgoing network, okay, or like we try to depends on which devices. Okay, so we know which device keeps sending, then maybe we can isolate that device. Okay, so they're possible. So this decision tree and neural network, we talk about AI, machine learning, and then we talk about deep learning. Okay, deep learning model. So we be like using the really complex data pattern. So we need to like identify the malware based on the network traffic patterns, all these, so we can train, so we can recognize, okay, they are possible um, some malware. Okay, so there's a patterns that we can prevent it. And when we talk about like when it's like the supervised learning, so possibly we can use called the random forest support vector machine, okay, SVM. So those like we can use for the task like intrusion detection. So where we can have like label data. Okay, so that be attack, not attack. So we can like feed all these data and train it. Okay, and if we are doing the unsupervised learning, we can use maybe called a k-means or the isolation like foster. So we can use it for the abnormality detection. So when there's no prior knowledge of the attack, all this like will be the algorithm we can use if you, so that the machine learning, maybe you know like some of these like algorithm. Okay, we are going to use. Okay, and in here will be like introducing how can we use them, and then how can we apply. Okay, and this model. Okay, in for our security. And how about the reinforcement learning? So we can use just here for some like adaptive security where the model learn from. Just like we need to simulate the attack so we can improve the defense over time. So this one will be like learning. So based on, if you remember like from the reinforcement, so we need to like learn based on feedback interaction. So if they will try to, if you know they, for the attacker, maybe they're looking for the open part. Okay, so when they try to scan, okay, so when they learned the learning model learning how to scan the port, then maybe you need to know, okay, so there are two ways. Maybe you're going to block the port, or like you want to guiding misleading the attacker. So there are different way for depends. Okay, so this one we really depends on the strategy. And for the anomaly detection, so the machine learning model can analyze those like behavior over time, okay, and detect some deviation. Those like, if let's say the thermometer try to sending they sending some unexpected communication, so it can indicate there being like already hacking attempt. Okay, so this like code detection. So maybe we create the threat. Okay, and then the IDS. So this system also can apply to analyze some income traffic and detect some malicious activity. Okay, so we can detecting those like DDoS attack based on their unusual traffic pattern, because you know they keep the sending package. Okay, so we can doing this one. And also we can help, okay, maybe using the machine learning to identify. So with those like vulnerabilities they in the devices, so including the configuration. Okay, they will try to can be scanning your configuration and okay, if your configuration the setting like this, potentially what's the risk, okay, or some like network traffic, okay, including, and then or some like based on past attack, so we can potential predict some potential probability. Okay, so maybe in the past attack they know, okay, because the firmware they will have a backdoor allowed to access, then they can scan it and then check the configuration. Okay, if they can either maybe try to update firmware or they fix it, or they have to like maybe close the port, or like setting some certain restrictions, or this. Also the, we call the threat intelligence. So this one can help us to analyze some external data source to focus on possible new threats. Okay, so some malware trends. So it may help also the risk assessment. If you remember in the cybersecurity, we talk about once a risk assessment. So we can also can help for the assess the risk based on the real time. Okay, some like historical data, so we can prepare for it. So this is for the risk assessment. Okay, and also how about we can use the machine learning for the encryption and the authentication. What's the machine learning based encryption can we use? Okay, but we talk about the blockchain to like and saying the data. Also, we can enhance the encryption algorithm, so we can edit by dynamically adjusting the encryption method to counter an emerging attack. Okay, so this way we can apply. Okay, um, also biometric authentication, so we can like improve some facial recognitions, or like let's say if we using the fingerprint maybe using for the smart lock, right? Facial recognition also can be used for camera, door lock with or your some other devices. Okay, and also like voice recognition system, nowadays those are devices, they will have a speaker, they have a microphone, and they try to listen what you're talking. Okay, so all this, then we have to secure. And so I say the lock right here, they will recognize the authorized user based on the facial recognition. Okay, and or the fingerprint. Okay, all this. Also, in the real-time monitoring in this direction or automated response, so of course they can provide the continuous monitoring, so it can doing like 24 hours, 24/7, so they can keep on monitoring those like smart devices, IoT devices for any sign for abnormal behavior or the threat, so they can check it. And if we're doing manually, because either we have to like spend lots of the cost, like 2 shift, 3 shift, like they have to work 24 hours, like make sure like 24 hours under monitoring. If no, then AI can help. Okay, and then we maybe provide prepare some automated response. So once they detect it, so the AI can automatically take action. So are they going to isolate and affect the devices as well as before? How can we isolate it? Or like they can like blocking those unauthorized traffic. So that's the response we can take once they detect it. And also we have some like real-time alert. So we can send an alert to the administrator in real time if they figure out there's some like potential breach occurs. Okay, this is for the real-time and automated response. Then how about the AI powered like cyber attack detection or mitigation, including malware detection. So if we can detect the malware, so which analyzes its behavior, or even if just a new variant is possible based on the patterns, so we can able of course we can like as a follow-up we can put it as a quarantine. Okay, and DDoS mitigation we can detect in the early sign before the DDoS attack. Okay, so they can automatically mitigate the impact. So it's way better. Like once they receive the DDoS, they will uh, occupy all your resource like processing power. Okay, so if we can like stop this connection in the early stage, then we can like block all the traffic. And in the phishing detection, maybe we can detect the phishing attempts based on the email content or traffic analysis. So all this can help. And when we talk about like those like possible like algorithm talk about it, we talk about like the decision tree, random forest, okay, and also the super vector machine. So we talk about like decision tree, we can classify the like detection attack. Random forest we say so it can use to improve the accuracy. So we can like combine multiple decision tree, okay, and the SVM, so we can use the called a binary classification task, like to classify, okay, is it under like is attack or no attack stage. So this one we can using to to detect some unauthorized device, like as by classifying their traffic or as a legitimate or suspicious. So this may be possible. Um, um, under the unsupervised learning algorithm. So you see that we talk about k-means, and then for k-mean, it can, we say we try to group the similar behavior, right? So some anomalies or their flags, so if they're not fit any cluster. So, and then we have a new one is called the DB scan. So HOS this is a density-based spectral like clustering. So we will find some anomalous data point in the dense like region of the data set. There's also we can use this algorithm, so we can identify some like unknown security threats with direct power labeling of the data. So it's a way. So we can make it more like without any label, that we will able to know, okay, it's possible. Okay, so some like abnormal this data point. Okay, and for the next part, the reinforcement learning. Okay, so we need the agent, that means the model, to learn some interaction with the environment, so including the network or talking to a device. And how can we optimize the security decision, like maybe based on we say that the rewards are penalties. Okay, so in the applications we maybe have some like adaptive defense system, so involve like based on maybe some new attack patterns, and also we can provide some dynamic decision making models. So right here, so usually put a lot nowadays, like if you total chatbox, so pretty similar. So we can managing those like access control in the smart environment. So that's what we can do. We in the reinforcement learning. And we talk about deep learning or the neural network. So this one is like helping to identify the complex pattern in the patterns. Those are neural network, including two ones called CNN, convolutional neural network, CNN. So if it's an image-based security, if like facial recognition, camera detection, okay. So something involved with image, then we can use the CNN. And if the recurrent neural network, so if something RN with for some like time series data, so maybe the network traffic data or like some thermostat or any data or like traffic lights any time, working with time, then we can use the RN to doing detection. So those that we can maybe we know some abnormal behavior over time, okay, or did they recognize the face for secure access? So they're possible. So we can use CNN or RNA of the neural network. Okay, so this one also this one is a subset of the deep learning. Okay, and what's the better way? Like, okay, what's some when we choose the right machine learning model for security? So this one will give you some classification. Let's say for the classification model, maybe if to something we already know the first, like device hijacking or detection, then we can use the classification model. Okay, because we can know what they are. Or some anomaly the detection model, then maybe we have something unknown, or we say the zero-based attack. Okay, so some unusual patterns or network traffic, then we can use the anomaly detection model. And if for some really complex security tasks, like for facial recognition, large scale attack detection, like maybe waiting for the command, then better we need to apply the deep learning model. Okay, so depends on the situation or like how you're going to apply. There's not that much, but right here we will just recommend there's a way to do that. So then we get and what's a better way like practice a pattern challenge apply. Of course, we need to do the regular update. Make sure that the models regular update handle the new first. Also the data privacy, because they when we train the AI model, we need to use lots of sensitive data. Okay, so we need to protect it. And also for the cross-platform security, because once you like want to combine the AI, the machine learning with transitional security module, let's say the firewall encryption, multi-factor authentication, that be careful like when you're sharing the data, okay, because they will interact together. Based on this, we need to, but we do still have some challenge and need to solve it. Okay, first one is that data privacy, because we need to have a large amount of data, okay, to train our model. Then is it possible to lead to some privacy concern? Okay, mishandle it. So this one we need to be careful. And for machine learning, AI, everything, we have one thing to talk about is a false positive or false negative. That means they may affect the legitimate data behavior. Okay, maybe they are supposed should be at normal, but we um say it's okay. That means a false negative. Okay, but sometimes it's there should be attack, but it shows it's not an attack. Okay, that's a false negative. Okay, then if we fail to detect it and then they allow to it, then it's worse than okay, let's say a human or like doing recovery. Then we need to like be careful of this one. So we do have a challenge on this part, and we're adversarial attack. So maybe they will manipulate AI model to bypass the security. Okay, so maybe they can poison the training data. Okay, so they're giving those like fake wrong labeling. Then what happened? Okay, or the complexity. Since we it's still challenging if you need to implement the AI in the large scale IoT environment, you know why not numbers growing higher. So the resource intensive, like also the difficulty to like really scaling up. So we still need to provide better solution right here. And based on this, of course, we need to do the regular model evaluation, looking for possible like evaluate, we train the model, so improve the security, make the accuracy higher, okay, and then data and normalization. So try to maybe use a privacy preserving technique. So like further learning to prevent the data misuse is possible, and also the model robustness. So can we develop more like a robust AI model so we can withstand the reversal attacks? Okay. Also, the collaboration, including can we working with other research institutes that is share some so intelligent improve the security so they are like would be better. Okay. And we say how can we apply the AI in the let's say home security, maybe the AI power camera or doorbell. So we can use the facial recognition, like rings. Okay, the ring using AI to identify some like known face or differentiate between family member or stranger. Okay, they will check. Okay, if they know if they know they are the family members, so they can just go and unlock the door. If they're a stranger, they mean they're not going to open it. Okay, and also they will detect that let's say some break-in something alert in real time, so it's good, right? And maybe for some wearables and health device we talk about as an example, so we may be like protecting like some health device. Okay, so the insulin pumps or like pacemaker. So or we can use the machine learning to detect some irregularity in the device behavior. So it also can be a kind of research topic too, like using AI to like detect the action. Like okay, if they wear the wearable, like let's say fitness band, or then when they fell down, so how can you detect emotion or like doing reporting? Okay, all this, so we can detect or like the heartbeat rate. Okay, so from the wearable devices, and how can alert the other user or like connect to maybe certain emergency. Okay, so all this. And if we look at the cities, well, so how can we enhance think that's mostly the infrastructure? Okay, maybe some AI powered like surveillance camera, so we can detect some suspicious like activity or traffic pattern, and those like traffic pattern can affect like they can better adjust the traffic light. Okay, so it can better for like manage. Okay, so maybe based on the traffic lights timing, so maybe real-time data. Okay, so or some we can prevent accidents or reduce our waiting time. So for like let's say if we talk about camera, so we know okay, most of cars they're waiting to go straight but no turning, then we have a longer time. Okay, go straight forward. Okay, or maybe in a cross. Okay, so maybe um they know which direction is more like busy, then given a longer time. Okay, so all this we can learn in real time. And another part we talk about industrial IoT, right? So IoT security. So maybe we can do some predictive maintenance in the factory. Maybe we can detect some anomalies in the machinery, prevent some costly breakdown or cyber attack. Okay, or maybe like we can detect because in the industry like factory. Okay, so what even for I say the machine, oh yeah, that cost pretty high. So it they are possible to detect maybe the when they try to produce certain products or like they can monitoring the performance or like some weird behavior of the machine, okay, the machine, then they can like notice earlier. So it may help. Okay, so they'll know which pass. Kind of really smart, just like similar to the sensor. If you know why the vehicles they know. Okay, so when they detect, why now you know. Okay, maybe your tire pressure is low. Okay, maybe some light is not working. Okay, so all this they know. Okay, of course they're using sensor, but for the machine learning, they can like learn the patterns data. Okay, which way will be better to solve it. So far, we quickly go through about our machine learning and using the AI. Okay, so how can we enhance it? So we have different machine learning models. We have like key technology right now, so we can like detecting the threat, automate some security response. Okay, or predicting some potential vulnerabilities. Um, it's really growing. So actually, especially some probably like household smart devices. Okay, they're using those are common. They will apply the AI. Okay, they will be getting more like crucial role. Okay, in the safeguarding, in the smart environment, and then keep learning. Actually, they are still like um evolving like really rapidly. Okay, so they continuous research and try to adopt. Uh, Adoption is essential. So we need to stay ahead of security challenge. And so far, that's it for our lecture related to the side the machine learning applying on our smart things security. Thank you.